Okay, so this is a problem that came from that Gelfand or Gelfand algebra book. And what it said was, it said, compute 11 cubed without a calculator, okay? And it gave us a hint. It said, hint, 11 equals 10 plus 1. Okay. And I thought, okay, thank you, Captain Obvious, for that. Why would that be helpful to know? Well, let's remember this. Let's remember if we take some number A plus some number B, and we actually square it, okay, that produces A squared plus 2AB plus B squared. If this is not just springing to mind, or if what I just did here seems inscrutable and terrifying, let me show you how I'm getting this. All you have to do is draw like a box. Like this. Cut the box into 4 pieces, make it look like a window. Okay, and then A plus B squared is just A plus B times A plus B. Okay, so there could have been a step up here where I wrote A plus B times A plus B. Okay, that's what A plus B squared is. Okay, that's A plus B squared. Okay, so we want to find out, how do we get from this to this? Well, up here we have A plus B, and then we're going to write it again, A plus B. And basically we just fill out this table and by multiplying. A times A is A squared. A times B is AB. B times A is AB. B times B is B squared. And here in the middle, these are the same, and they add to be 2AB. So you just start with the A squared, and you write A squared. And then you, instead of writing AB plus AB, we just write 2AB. So it's 2 times AB plus B squared. This is called binomial expansion. So once you have this concept, you can actually use this hint. All right, so let me walk you through the process. So if A plus B squared equals A squared plus 2AB plus B squared, then let's think about A plus B cubed. Okay. Well, this does not need to be hugely complicated. All you have to do is think, well, okay, A plus B cubed is really just A plus B times A plus B times A plus b. Well, we've already dealt with this. We already know that a plus b times a plus b, well, that's just a plus b squared. And we've already learned how to expand that binomial. So what we could write is we could write this as a plus b cubed equals a plus b squared times a plus b. Okay, now we've already learned that a plus b squared is a squared plus 2ab plus b squared. So now what we have is we have a plus b cubed equals a squared plus 2ab plus b squared. And then what we're saying is we're going to multiply this whole thing times a plus b. Okay. Well, this is not difficult because, well, let me walk you through it to show you that all you're really going to do is multiply each one of these terms by both of these terms and just add everything. You're just going to be adding everything up. So once again, we're sticking with this a plus b cubed. This is what we're finding each time. Each of these are equivalent expressions. This is string of equal signs. So now we're going to start a squared times a. All right, so what I'm doing is I'm saying a squared times a. Well, that's a cubed. Okay. And then a squared times b is a squared b. Okay, so now I'm done. You want to think about it. I'm done with the a squared. All right. Now I'm going to do 2ab times a. So that's going to be 2a squared b plus 2a squared b. Because I'm multiplying 2a squared b times a. And so the 2 and the b don't change, but the a and the a multiply to be a squared. So that's how I got 2a squared b. And then I'm going to multiply 2ab times b. Well, this time the 2 and the a won't change, but the b's multiply. So I got plus 2ab squared. Okay. And finally, we're going to do b squared times a, which is just ab squared, plus b squared times b, which is b cubed, okay, plus b cubed. So now look at the complexity of the mathematics that you did, and it's all from first principles, and there was nothing really hard about any individual step. So what we did all of this in order to do 11 cubed. So this whole business here was just so we could learn how the framework we were going to use to do this, okay? What we've learned how to do is take two terms. This is considered now a binomial, all right? This is a binomial because bi means two, right? So there are two, and nomial here, we'll think of it means terms, two terms, all right? So we're working with binomials here, and we've now learned how to cube a binomial. Well, that's exactly what we have to do here because we're going to cube 11, and 11 is just 10 plus 1, and so we're going to do 10 plus 1 cubed. And so we are literally going to follow this exact process, only with numbers instead of letters. So we're going to go down here and write 11 cubed equals, open parentheses, 10 plus 1 cube, which equals 10, open parentheses, 10 plus 1 squared times 10 plus 1. Now, as tempting as it is, we are not going to just say, well, 10 plus 1 is 11. We're not going to do that. We're going to treat this as if these are our letters. You know how we weren't mixing the letters before? We're not going to mix the numbers. We're going to follow this procedure here. Okay, so we remember when we saw a binomial squared, we saw that it did this. It became the first term squared plus 2 times the first term and the second term plus the second term squared. So that's what we're going to do. We're going to go back here and say, well, okay, 11 cubed equals 10 plus 1 cubed. And now we're going to expand this binomial just like we expanded this binomial here. And so we're going to say, instead of a squared plus 2ab plus b squared, we're going to say 10 squared, and we'll put this in parentheses, 10 squared plus 2 times, and then it was 2ab. Well, this time it's going to be 2 times 10 times 1 plus b squared. Well, the b here is 1, so it's going to be 1 squared. So we'll go put 1 squared, okay? And then we're going to go ahead and close off those parentheses, and then we're going to write 10 plus 1, okay? Well, now we're here where we're going to do this distributive property thing, okay? So let's do it. Let's go. Well, okay, so we're still trying to find 11 cubed, haven't lost sight of our ultimate goal. And we remember that that's just 10 plus 1 cubed. And now we're actually going to start distributing this. So we're going to do 10 squared times 10. Well, 10 times 10 is 100. 100 times 10 is 1,000. So, but I'm just going to write 10 cubed for now. All right, we'll get to the numbers, you know, the bigger numbers in a minute. 10 cubed. All right, now how about this one? So I'm going to do 10 squared times 1. Well, that's just 10 squared. So 10 cubed plus 10 squared. All right, plus. Well, now it's time to take this 2 times 10 times 1 and multiply it times this first term. And we're going to use this exact thing we did here to do that. So remember, we're multiplying 2 times 10 times 1 times 10. So it's 2 times 10 squared times 1. Okay? And we'll put these in, I'm going to put it in parentheses so we don't get confused. So that's that one. And now we're going to do 2 times 10 times 1 times 1. Okay, we're going to write it out, even though it seems trivial. We're going to write it out. We'll go ahead and put it in parentheses so we don't get lost. 2 times 10 times 1 squared, right? Because it's 1 times 1. And we know that 1 times 1 is 1, but we'll get to that in a minute. This is 1 squared, okay? And finally, we have 1 squared times 10, okay? So this is where we are here. Well, 1 squared times 10 is just 1 squared times 10. Okay, that's like a term, and that needs to be added here. And then we do 1 squared times 1, which is 1 cubed. Okay, so I'm going to put this in parentheses as well and say plus 1 cubed. So just like here we ended with b cubed, here we end with 1 cubed. Okay? And so we've now replicated this line. And all that is left for us to do is to just go from, 10 cubed to the actual number. What is 10 cubed? Well, we said 10 squared, 10 times 10 is 100. 100 times 10 is 1,000. So this is 1,000. So we're going to just write another line here. And remember, we're trying to find 11 cubed. And we know that that's 10 plus 1 cubed. And that's equal to, now 10 cubed is 1,000. 10 squared, well that's 10 times 10. That's 100. So I'm going to write 1,000 plus 100. Now we're going to do this. 2 times 10 squared times 1. Well, we use PEMDAS, which means we do parentheses, exponents first before we do multiplication, division, addition, subtraction. Please excuse my dear Aunt Sally, parentheses, exponent, multiplication, division, addition, subtraction. So here we have the exponent. We're going to have to do that first. 10 squared is 100. And then we could do 100 times 2 is 200. 200 times 1 is 200. So we have 200 here. That's what that evaluates to, just 200. Plus, now let's do this. Again, start with the exponent. 1 squared is 1 times 1, that's 1. So 1 times 10 is 10. And 10 times 2 is 20. So this is 20. Plus 1 squared is 1 times 1, which is 1. 1 times 10 is 10. So plus 10. Plus 1 times 1 times 1 is 1. So 1 cubed is 1. Just put a 1 out here, okay? So now we just have to combine these. And so our final line, I think we're about to get it. We're going to do 11 cubed. Remember, that was equal to 10 plus 1 cubed. Equals, and then we're just going to add. So 1,000 plus 100, that's 1,100, plus 200, now we're at 1,300, plus 20, that's 1,320, plus 10, that's 1,330, plus 1, that's 1,331. 1, 3, 3, 1. Okay, now let's check and see if we're right. Hey Siri, what is 11 cubed?
11 raised to the third power is 1,331.
And there we go. And so we are correct because Siri told us we were correct. And in the future, when the AI becomes self-aware and takes over the world, we will be obedient to Siri. So the real moral of the story is trust the artificial intelligence. No, there is an easier way. So this is how I would teach this. Like this, to me, is very satisfying because it takes binomial expansion and some of the properties of algebra that we've learned, and it applies it to integers. And it shows us that we can do what seems to be this kind of abstract, complex mathematics. It makes it real, and we were able to compute real things. But my mom actually had an easier way of actually computing this cube value. And so I want to show you what she did before she saw what I was going to do, which in most cases, what I end up doing seems like a complete nightmare versus the easier way. So let me just carve out this little area over here to show you the alternative method that my mom showed me. Okay, so again, let's start with this 11 cubed idea, all right? Well, remember, the hint was that that was equal to 10 plus 1 cubed. So here's what my mom did. She said, well, let's start with 11 squared, okay? And she said 11 squared is equal to 121. All right? And then what she did is she multiplied that by this number. So whatever number was sitting right here. So she multiplied 121 times 10. And then she added to that number plus 11 squared. Okay? So let's walk through this. So remember, 11 squared is 121. So when we walk through this again, so you understand what she's come up with. She's saying 11 cubed equals 11 squared times 10 plus 11 squared. Is she right? Well, let's see. So 11 cubed equals 121 times 10 plus 121. And so 11 cubed equals 1210. You just add a 0. 1210 plus 121. Okay, let me fix this. I'm erasing my own writing. Okay, and so now let's ask Siri. Hey Siri, what is 1,210 plus 121?
It's 1,331.
Oh, so here we end up with 1,331. So if you just compare the quantity of nonsense on the board to my mom's alternative way of doing it, this was very clever, and it turns out that this works for especially with the cubes. It works for any number that you plug in. So if you were to, for example, if you started with 5 cubed, I'll show you that just as a final. We'll stop there after we show you this. So this is Mom's recipe here, just to show you that it works with any value. If we plug in 5 cubed and we say, well, remember that is just 4 plus 1 cubed. Okay. So her process would be 5 cubed is really equal to, let's follow her procedure, 5 squared times, not 10, but whatever number is sitting here. So times 4 plus 5 squared. Okay, so finally here we'll just figure this out. See, 5 cubed is small enough that we know it in our heads. 5 times 5 is 25. 25 times 5 is 125. So, but let's see if that, like the procedure worked. 5 squared is 25. 25 times 4, that's going to be 100, plus 5 squared is 25. So that equals 125. And, that is correct. And so here we've learned a lot about how to cube numbers, both using the kind of algebra and then what you might call like somebody's number sense or mental math. This is just how my mom thought of it. And obviously, if you just look at the quantity of text for both of the methods, this was shorter. Where we got sidetracked into complexity was when the power started to get higher. And then we kind of lost, this trick didn't seem to really, we kind of got mentally lost as to what we were doing. But anyway, I hope this video was at least somewhat entertaining, and it just goes to show you that it doesn't matter how much you learn as a child, or how much education you have, or how many years that you end up doing that thing. Mom is always right.